Today we're going to talk about the integers, and we're going to cover all operations: addition, subtraction, multiplication, and division. Let's start off with addition. When adding integers, if signs are the same, add and keep the sign. For example, -4 plus -4. In this case, the signs are the same, so if we follow the rule, we will add 4 plus 4, and we will keep the sign, which both 4's are negative, therefore our answer will be -8. Another example would be 5 plus 5. If you look at 5 plus 5, the positive sign, or your plus sign, may not be in front of the number. But if there's no negative in front of the number, we know that the number itself is positive. So in this case, both numbers are positive, therefore we just add 5 plus 5, and we get 10 as our solution. So our answer is +10. Let's try another problem with negatives. Let's take, for example, -6 plus -3. Again, if we look at both the signs, we'll see that they are both negative. Because they're both negative, we know we're going to add the numbers together. So 6 plus 3 equals 9. The signs are both negative, therefore our answer is -9. Now, along the operation of addition, we dealt with if signs were the same. If signs are different, things are a little different. The rule states if signs are different, subtract smaller absolute value from the larger absolute value and keep the sign of the larger absolute value. To truly understand this rule, we have to understand the concept of absolute value. When you think about absolute value is the number of spaces a number is from 0 on the number line. For example, if we take a look at the number 3, if we look how many spaces 3 is from 0 on a number line, we can count them. 1, 2, 3. So the absolute value of 3 equals 3. Now let's look at the number -3. We want to figure out how many spaces -3 is from 0 on a number line. So again, we can count 1, 2, 3. So the absolute value of -3 is also 3, which tells us something very simple. Absolute value can never be negative, and whether we're talking about a negative number, such as -3, or we're talking about a positive number, such as 3, we know that the distance, -3 and 3, are from 0 on a number line are the same. It is 3 spaces. Well, it's important to understand absolute value because we're going to apply it to adding integers if they have different signs or they have unlike signs. So for example, first thing we want to do if we notice the signs are different, and in this case we notice the signs are different because 4 is negative, 6 is positive. The signs are different, so the rules tell us we need to subtract. Well, we need to subtract what? We need to subtract the smaller absolute value from the larger absolute value. Well, the absolute value of -4 is 4. The absolute value of +6 is 6. So we're going to look at those two absolute values and decide which one is smaller. Well, obviously 4 is smaller than 6, so the rule states we want to subtract smaller absolute value from the larger. So 6 minus 4 is 2, and we want to keep the sign of the larger absolute value. Well, if we look back at both absolute values, the absolute value of -4 is 4, but it started as negative. The absolute value of 6 is 6, but it started as positive. So we want to keep the sign of the larger absolute value, which is 6. It started as positive, so our answer will be positive. In another example, -8 plus 6, if we look at the two integers we have in our statement. The absolute value of negative 8 is 8. The absolute value of 6 is 6. Again, we know that our signs are different, so we know we're going to subtract. We're going to subtract smaller absolute value from the larger. Larger absolute value is 8. Smaller absolute value is 6. 8 minus 6 is 2. And we're going to keep the sign of the larger absolute value. Well, if we look, the larger absolute value is 8. And the sign that was attached to 8 was originally negative. Therefore, our answer will be negative. In this case, negative 2. Let's try another one of those. If we look at negative 10 plus 6, we notice that the signs are different. 6 being positive, 10 being negative. Because the signs are different, we know we're going to subtract. And again, the rule states subtract smaller absolute value from larger absolute value. Well, the absolute value of negative 10 is 10. The absolute value of 6, or positive 6, is 6. So we want to subtract 10 minus 6, which will give us 4. Now, if we go back and look at our absolute values, the larger absolute value is 10. The rule states keep the sign of the larger absolute value, but it was originally negative 10. So we want to keep that negative sign, and we get negative 4. Now, you're probably not going to apply this level of work every time you do integers, but it's important that you understand the rule and what the rule refers to when we talk about absolute value and how that rule applies to the addition of integers. Next, we're going to take a look at subtracting integers. Now, subtracting integers can be a little bit confusing sometimes because what we actually end up doing when we subtract integers is we end up adding them. So when we subtract integers, we want to rewrite the subtraction problem as an addition problem. And once we do that, all the addition rules that we learned earlier will apply to the subtraction problem. For example, let's look at negative 4 minus 4. If I want to turn negative 4 minus 4 into an addition problem, it's really rather simple. Negative 4 will stay the same. I'm going to put an addition sign in the middle. Now the subtraction sign doesn't just disappear, but it attaches itself to the number to the right. In other words, negative 4 minus 4 implies that this 4 is in fact negative. So if we want to turn negative 4 minus 4 into an addition problem, we just add the addition sign, and then instead of it being a minus, we're just going to write negative 4. So once we rewrite the problem as negative 4 plus negative 4, then you can see that our addition rules apply. Well, if negative 4 plus negative 4 signs are the same, if we look at the signs, they are both negative. Our addition rules say if signs are the same, add the numbers, keep the sign. 4 plus 4 equals 8. Both numbers are negative, therefore our answer, negative 8. Now let's take a look at this problem. We have negative 6 minus 2. And again, we want to turn our problem into an addition problem, so we're going to rewrite it. Negative 6 will stay the same. Keep change. Plus negative 2. Negative 6 plus 2. Signs are the same. We'll add the numbers together. 6 plus 2 is 8. Both numbers are negative, therefore our answer is negative 8. Here's another example. We have 4 minus 5. We want to rewrite the problem as an addition problem. 4 plus negative 5. And when I said keep change the last time, we're going to keep the 4, we're going to change the minus sign to an addition sign, and we're going to change the 5 to a negative 5. So keep change. Once we've written the problem as an addition problem, our addition rules apply. Signs are different. Because signs are different, we want to subtract smaller absolute value from the larger absolute value. Well, the absolute value of 4 is 4. The absolute value of negative 5 is 5. So we want to subtract 4 from 5, and we will get 1. Now, the absolute value of negative 5 was 5. It's a larger absolute value. It was originally negative, therefore our answer is negative. Alright, let's do one more example, and we will just do it without all the extra writing so you can see what it looks like. We'll do 5 minus 10. We will first rewrite the problem as an addition problem and apply keeps, change. So we have 5 plus negative 10. Signs are different. We want to subtract the smaller absolute value, 5, from the larger absolute value, 10, which will give us 5. The larger absolute value was originally negative, therefore we would keep the negative sign, and our answer is negative 5. Now, this next subtraction problem, it can be a little tricky for students sometimes. They get a little confused and aren't sure what to do. So I'm going to try and explain the process on a number line. And to take a look at 2 minus negative 1, I first want to take a look at 2 minus 1 on a number line. If we were going to subtract 1 from 2 and model that on the number line, we would start at 2 and we would jump backwards or to the left 1 space. And we would see that 2 minus 1 is 1. Now, if 2 minus 1 is 1, then it's not really possible for 2 minus negative 1 to also be 1. So something changes. And what happens is if we are subtracting a negative, our directionally actually will reverse. In other words, we will start at 2, and instead of going back 1, we will reverse and go forward 1. So 2 minus negative 1 is actually positive 3. Another way to think of this is, again, keep, change. When you see minus and negative, keep the first number, change to an addition sign, change the second number to its opposite, or positive. 2 plus 1, again, is 3. So let's look at another example of that. Again, if we wanted to, let's say, subtract 3 minus 2. Okay, 3 minus 2, we would start at 3, and we would go back 2 spaces. 1, 2. And our answer would be 1. Well, let's say we wanted to do the problem 3 minus negative 2. Well, again, we would start at 3, but remember what I said. Once we start, we see that minus negative. We want to reverse our direction, and we're going to move 2 spaces to the right. So 3 minus 2, if we apply keep, change, becomes 3 plus 2, which is 5, which is the same thing we got on our number line right there. Now let's take a look at multiplying and dividing integers. I think multiplying and dividing integers are really pretty simple and pretty basic forward. We're going to do our multiplication and we're going to do our division like we normally would if we were just dealing with whole numbers or natural numbers. But there's a little bit of a difference since, we may have some negatives in there. If the signs are the same, your answer is always going to be positive. That means if they're both negative, your answer will be positive. If they're both positive, your answer will still be positive. If signs are different, answer is always negative. So if you have different signs, your answer is negative. For example, let's take a look at these 2 multiplication problems. 4 times 4 is equal to 16. Now, negative 4 times negative 4, because signs are the same, we're going to multiply as usual. 4 times 4 is 16. Signs are the same. Answer is always positive. So 4 times 4 and negative 4 times negative 4, their answer are both 16. They are both 16. Now let's look at a case where signs are different. Again, 4 times 4, we know that is 16. But if we look at the problem underneath, negative 4 times 4, negative 4 times 4, signs are different. We multiply 4 times 4 together, we get 16. Signs are different though, so we know our answer is negative 16.